here we have the SRE mindset for MLOps, or the site reliability engineer mindset for MLOps. Really in my background, I've dealt with a lot of system reliability problems, including building machine learning systems that used social media reach to grow the platform. And also I currently consult with companies on machine learning operations and teach MLOps. And so really this background has led me to think about some of the ideas around what's happening in the current industry, as well as the things that I've done in my career. And one of the things that comes up immediately is the concept of preemptive risk discovery. So how would you do this in a data engineering or MLOps system? Well, first up is automation. If you don't have automation, there's a risk to your organization. So can you automatically deploy? Can you automatically test? Finally, in monitoring, right? If you're not able to monitor what's happening, you don't have the ability to really use data or use data science to see what's happening in your system. And then quality control. So are you automatically testing? Are you automatically linting your code? If you don't do this, you're really rolling the dice. And then another thing that's really relevant to today's era is this concept of an academic tool chain, where you're building maybe like God-like tools that are really useful in academics, but then cause a problem when you go into production. So really the way to look at this is DevOps and MLOps are tightly correlated. If you don't have DevOps, you can't do machine learning operations. So if you don't do automation, infrastructure as code, then you can't get to the top of the pyramid here, which is you can automate data automation, you can have platform automation, you can have MLOps. And this is really the hierarchy of needs for machine learning engineering. One way to put this is that there's an MLOps rule of 25, right? There's no silver bullet. You can't have a particular philosophy that solves all your problems. You have to put hard work into all of these categories. You have to have hard work into DevOps. You have to have hard work into data. You have to have hard work into models. And you also have to have hard work into business. Now, if we get into monitoring, one of the critical things to think about with monitoring is that it's data science for software systems. So if you're not monitoring your system, you're not doing data science. And this is kind of ironic if your company is practicing data science, but then you're not actually doing data science on your software system because you're not doing monitoring. One of the ways to think about this is a quality control system. So are you being able to develop in a reproducible environment that's identical to production? Things like GitHub code spaces solve that. Do you have access to GPU? So can you actually train things in a fast manner by doing the same thing you're going to do into production? Are you using the best tools available? So are you using things like Copilot, for example, that helps you write code in the most efficient manner? It's important to use the latest technologies to reduce errors. And then finally, are you using cloud-based systems like continuous integration and deployment to further enhance your ability to write code? So one of the things to talk about here is that with a reproducibility of a cloud-based system, you have several advantages. You can build with a container, you can build configuration from the start, and you can also use the compute and storage so you don't have to actually have a weird environment that isn't a production environment. As I mentioned before, Copilot is a great way to have an enhanced feedback loop, right? So you have a better prompt, you lint, you test, you execute, you format. So you're increasing your ability to diminish bugs in your code. So you're enhancing your ability to write high performance code. And then if you take a look at these cloud-based systems like GitHub Actions for continuous integration and delivery, it allows you to put the exact same steps that you do in your development environment into production. So it could be use GitHub Actions to push a container to Amazon ECR, which then triggers a build to App Runner, and that deployment then serves out a fast API endpoint. So in a nutshell, one of the things that you want to avoid is the academic data science toolchain. Some of the things that happen in a academic sense that make a lot of sense there, but don't make as much sense in production are notebooks being the only way that you develop software systems, because notebooks are brittle and they're not really able to be leveraged in terms of software engineering best practices. Another one is God tools. So you have tools that have, tons of different software installs all inside of one environment, or package everything up in a way that would work really well in one box. but have a problem in production. And then voodoo tools, right? So a good example of this is you have a voodoo box under your desk that everybody's connecting to in, maybe in your lab as a biologist. You don't want to do that in the real world. You don't want voodoo boxes. You want to eliminate these kinds of tools. So the production first mindset means that you do the exact same thing in development as you do in production. Use things like containers, use cloud-based environments, and you also use continuous integration and continuous delivery.